Hello everyone, it's Mads again and welcome to the lesson 3 of our module 2, still in week number 2. Now in this session, we're going to discuss about the last method for analytical method, which is the component method of adding vectors. But before we proceed to the details, let us have our learning objectives. So the learning objectives that we're going to accomplish now at the end of this video lesson, you are expected to rewrite a vector in component form. And the second one is you're expected to calculate directions and magnitudes of resultant vectors using component method. To begin, let's define what is component method. Anyway, class, component method is widely used in trying to extract vectors which is do not coincide with x and y axis, meaning to say if we have a lot of vectors, or we have 2 or more vectors that we have in our Cartesian plane, we're going to breaking up these vectors into its component and try to find the resultant vector of that by simply resolving those vectors in its component. So what are those components that we have in component method? The first one is the horizontal component or the x-axis of the vector, and the second one is the vertical component or the y-axis of the vector. So these are the components of vectors that we're going to consider in trying to breaking up vectors into its components. So these are the steps in resolving vectors. The first one is to resolve vectors into its x and y components. And the second one is we're going to solve for the r sub x of that vector, which is a resultant vector in x component. And the third one is we're going to resolve for r sub y, or the resultant vector in y component. And the fourth one, we're going to solve for the magnitude of that resultant vector. When we say magnitude of that resultant vector, the total value of the combined vectors from x component and y component. And the last one is we're going to solve for the direction of the vector, and from that we can simply write down the final answer for the magnitudes and directions of the resultant vector. Having said that, let's go to our conceptual understanding. Okay, so let us have the conceptual understanding of the component of vectors or component method, so that we have a uniform understanding of the terms that I am going to use in solving the sample problem that we have. Now, in vector resolution, for example, we have here a vector that has a value of 5 newtons and an angle of 30 degrees that, let us say, located in the quadrant 1, which is the direction of north and east. Now, in resolving this vector into its component, we're going to consider the x component and the y component of this vector. Now, to do that, let us just draw here an imaginary line so that we can indicate the component of this vector, either be in x or in y. So first one is, in this case, I'm going to draw here a simple imaginary line that represents the vertical component of our vector, and we can also draw here an imaginary line to represent the horizontal component of our vector. So looking at this diagram, we can simply label this this side as obviously the x component of that vector. So this is a sub x, and this a sub x is just be equals to the value there. And we have also here the y component of our vector. We can label this one as a sub y, and also this one is a sub y. Now, considering this one, we can use either be this part of the figure, or we can use this one. Now, to do that, let us have to consider again, go back to the basic trigonometric functions, because as I said, we will need the help of that in dealing with analytical method. Now, to do this one, to solve for, since let us try to recall again our towa. Now, to do this one, let's have the x component of this vector. For x component of this vector, take note that our vector is a sub x, and we have also given value here, which is the a sub vector a here, or the longest side of the triangle here. Now, we can simply use this function here, the so here, or we can use the function here, which is ka, because in x component, or in solving the x sub x component, obviously this is in the adjacent side of the diagram. So we can write as cosine theta is equals to adjacent is a sub x over the hypotenuse there is obviously our vector a. Now, cross multiply this one, this becomes a sub x is equals to vector a cosine of theta. Now, this cosine of theta here now is the x component of this vector. Now, let's go for the y component of this vector. For y component of this vector, we can use this one, the so function here. So, applying this one, sine theta is equals to the opposite side, a sub y, and the hypotenuse side is the vector a. Cross multiply this one, this becomes a sub y is equals to vector a sine theta. Now, this will be now our y component for this vector. So, we will label this one as x component. X component. And this one is our y component. So this is now the basic principles that you need to understand and you need to remember as we go along in our sample problem, so that we could have a uniform understanding of what I'm showing to you in answering the sample problem. You can remember this one, or you can memorize this formula and try to familiarize the process that we have presented here, so that you could easily understand and also solve the unknown value for our component method. Okay, you can pause this video and copy this one. Okay, now let us apply that in our sample problem. So for example, we have here a vectors. So the problem is we're going to solve for resultant vector and the direction of these three vectors. The vector A, or the first vector, is 10 newtons, 45 degrees north of east. And the second vector is 15 newtons, 60 degrees north of west. And the third vector is 20 newtons, 30 degrees south of west. So I just already plot the vector so that we can utilize our time. Now for vector A, that's north of east, 45 degrees. So I just this is just an approximation. I don't really measure the angle with the protractor, but I just assume that this is 45 degrees because we are in analytical. We don't need to plot the vector in an exact measurement based on our protractor. So for vector A, this is 10 newtons, 45 degrees north of east. So this is the graph here, or the line here. Now for vector B, 15 newtons, 60 degrees north of west. And for vector C, this is 20 newtons. 20 newtons, 30 degrees south of west. And we're going to find now the resultant vector and direction of this one. Before we solve this one, I just want to introduce some basic concept here, or principle here, that we need to consider when solving this one. So let's have this conventional sign here. I will just put here convention. sign. So in going here, try to remember that if the vector is going here, this line, this is positive, and if this is going to the left, that is negative. And if the vector is going upward, that's positive, and if the vector is going downward, it's negative. So this is just a basic conventional signs that we need to consider when solving this one. Okay. Having said that, let's go to the solution. So the first thing here that we're going to do is to redraw the diagram here based on its components. That means we're going to resolve this one by x and y axis components. So let's start from A. So we'll draw here an imaginary line. This one. And this is A sub x. And this A sub x is just be equal to the A sub x here. And this is A sub y. This A sub y here now is just be equals to the A sub y here, this vertical line here, or the north line here. And for vector B, I will do the same here. So we'll draw a line here, imaginary line. So this is, I will put here, this is a B sub x. This B sub x is just be equal to the B sub x there. And B sub y here is just be equals to B sub y there. And same goes to vector C. This is C sub x here, and we have also C sub x here. We have also C sub y there, and this is C sub y. This is not C sub y. This is sorry for that. That's an error. This is vector C. Vector C. So that means if we're going to draw this one individually by vector, this will originally or this will best represented by this diagram here. This will be our basis in solving this or resolving these vectors into its components. Now always remember that in dealing with x-axis, we are using this formula in solving for the x-axis of each of the vector that we have. So in x-axis, we're going to use the cosine function, and for y-axis, this one, for y-axis, we're going to use the sine function for solving that y-axis. Okay, let's go for, let's try to solve for the r sub x. When we are, let's go back to again to our steps here so that we can be guided properly. So we already did this one. We resolve vectors in x and y components. So we already distributed that. So we've done this steps, step number 1. Now we are now in step number 2, which is solve for r sub x. As you can see here, so step number 2, it says that we're going to solve for r sub x after resolving vector into its components. So let's go for r sub x. Solve for r sub x. Now r sub x is, or vector r sub x is just a summation of all vectors in x component. Again, r sub x or vector r sub x is just a summation or total of all vectors in x component. That means if we're going to put this one into equation, this becomes, so first one is vector A. So this is A sub x. Now A sub x is positive. So we go to B. Now B now, vector B now or B sub y now, B sub x now is in this area here or in this quadrant here, which is, this is in the negative sign. So this is this becomes minus B sub x, or let us say this is vector B sub x. Now for C sub y, still in the down part or in the quadrant 3, meaning C sub y is here, this part of the Cartesian plane here. That is why C sub y is negative. But our focus now is C sub x. Since C sub x is also in this quadrant, in still quadrant 3 I mean, in which C sub x here is just be equal to the C sub x there, which is this one is in the still negative value or sign. So this means our C sub x here is minus C sub x, vector C sub x. So this will be now the equation for solving for the resultant vector in x component. Okay? Remember that A sub x and B sub x and C sub x is also represented by this formula here. So A sub x is equals to vector A cosine theta. Same goes to vector B. Vector B sub x is equals to vector B cosine of theta. Since, as I said, in x component, in dealing with x component vectors, we are using cosine function. So that means we are going to extend this formula. So this becomes A sub x here is just be equals to vector A cosine of theta, since A sub x is equals to A cosine theta. So we will just use this one to substitute for A sub x here. So vector A cosine theta minus, again the same also the same function, is equals to vector B cosine of theta, and also for C, vector C cosine of theta. Equals, continue, we substitute the value for its vector here. So for vector A, this is equals to 10 newtons. Cosine, let's check, that's 10 newton. Okay, it's correct. 10 newton cosine of 45 degrees minus, for vector B, that's 15. So 15 newtons cosine of, what's the angle of vector B? 60 degrees minus, for vector C, 20 newtons, angle is cosine of 30 degrees. So get your scientific calculator because we cannot compute this one. So we cannot compute that manually. So we really need our scientific calculator. So get your scientific calculator and try to compute this one. So in my calculator, the value that I have computed here is, this is 10 newtons. Cosine of 45 is, that's equals to 0.707 minus 15 newtons. Cosine of 60 degrees, that's equals to 0.5. Try to recheck this one, class. Try to recheck this one so that you can also practice your calculator. And for C, this is 20 newtons. Cosine of 30 degrees will give you 0.866. Okay, the next one is, you multiply this one. Multiply 10 newtons to that and do the mathematics of this one so that we can arrive at the final answer. My answer here is negative. This is negative 17.75 newtons. Try to recheck if this is correct. This is based on my calculator here. So this will be our r sub x, vector r sub x. My vector r sub x now, or the total vectors in x component, is equals to negative 17.75. this one. So we already have the step number 2. It says here that we're going to solve for r sub x, and we already did that, which is this one, this value here. Now we will proceed now to step number 3, which is solving for r sub y. Now we're going to sum up all the vectors here in y component. So let's try to use another color so that we can simply identify our resultant vector in y component. So solve for let's try to adjust our camera a little bit. Okay, solve for r sub y. So vector r sub y is equals to, again, all the vectors in y component. Vector a sub y. Vector a sub y is still positive. And how about vector b? B sub y, still positive. So that's plus b sub y vector. And how about vector cy? Vector cy is here. So this is negative. So negative vector cy. Expanding this equation, again, I will go back to the our original vector resolution here so that we can evaluate or we can check our formula. So for y component, we're going to use the sine function here, which is here, this one. So vector a sub y is equals to vector a sine theta, or you can just simply replace the letter here depending on the vector that you are solving. Okay, so we will expand this one. This becomes equals to vector a sine theta plus vector b sine theta minus vector c sine theta. And we substitute the value for a sub y here. For vector a, still 10 newtons. Sine of 45 degrees plus vector b is 15 newtons. 15 newtons sine of 60 degrees minus our c here is 20 newtons sine of 30 degrees. Okay? 10 newtons is equals to sine of 45 degrees is equals to, that's still the same for a cosine function. That will give you 0.707 plus 15 newtons. Sine of 60 degrees will give you 0.866. 0.866. Try to recheck this one, class. Try to recheck this one so that we can evaluate our answer. And the vector c here is 20 newtons. 20 newtons. Sine of 30 degrees. That would give you 0. That's 0.5. Okay, do the mathematics of this one. So here, do the mathematics of that. So the answer is, based on my computation, this is 10.06 newtons. You can recheck this one in your calculator, class, so that we can evaluate if this is correct. So now the r sub y here is, based on my computation, is the value is 10.06 newtons. So this will be my r sub y. So we already did the number 3, step number 3 here. Now we go to the step number 4, which is solve for the magnitude of the resultant vector. For step number 4 here, the magnitude here is the total resultant vector in x and y component. So we are going to combine that. Okay, so let's now proceed to step number 4. So step number 4, I will just set aside this one and grab another paper here for the continuation of our solution. Okay, now Let's solve for resultant vector. To solve the resultant vector, let us try to get first the given value here. So for r sub x vector, this is negative based on this one. This is negative 17.75. So 17.75 newtons. And for vector r sub y, this is equals to 10.06 newtons. So this is 10.06 newtons. So we are going to draw this one, and we're going to make the final shape of our vector, or the final graph of our vector. Now this is r sub x. R sub x is negative value. Never mind the magnitude here. We're now focusing on the sign of that resultant vector. So for r sub x, this is negative. That means this vector r sub x is going to west. Now if I draw that, it becomes like this. So for vector r sub x, this is going to west because that's negative. So this is now my vector r sub x. Now for r sub y, the positive, obviously that's going to north or upward. So this is my vector r sub y. So the resultant vector here that we're going to find is located here. Again, the resultant vector is connected from the tail of the first vector going to the head of the last vector. So this is now our resultant vector. So we already computed the value of r sub x and also the value of r sub y. As I said a while ago, in our lesson, in our analytical method, this if the given value, or if r sub x and r sub y, or if the y component and x component are given, then we can simply proceed to the Pythagorean theorem by applying Pythagorean theorem in finding the resultant vector of this one. That means I will solve for r using Pythagorean theorem. So to solve for r, this becomes resultant vector is equals to square root of r sub x squared plus r sub y squared. So it doesn't matter if this is negative or positive because we're going to square that value, so that still becomes positive. So I will neglect the negative sign here because still it becomes positive if we perform this operation here. So this becomes square root of 17.75, never mind the sign there, the negative sign there, 17.75 newtons square plus 10.06 newtons. Or if you want to be more detailed on your answer, you can put negative. There's no wrong with that. So this becomes like this. Now performing this one using our calculator, since obviously I don't have a calculator, but I scientific calculator, I did this one in my mobile phone. So you try to recheck this one so that we can verify if this is correct, because I just use my mobile phone calculator. So this is equals to, based on the value that was taken from my mobile phone calculator, this is equals to 20.4 newtons. So the resultant vector here is equals to 20.4 newtons. Okay? So we already solved the If we go back to this one, we already solved the resultant vector and now we are in the direction. And if we go back to our steps here, we already did these steps. So we are now in the direction. So we're going to solve for direction. Okay? To solve for the direction, where is the direction here? Direction is located here. So this is now still question mark. Okay? So we are going to solve for that. Solve for direction. So we're going to use tangent function because r sub y and r sub x are all given. So this is tangent theta is equals to, opposite is r sub y. This is r sub y over r sub x vector. This is absolute value. All this one is absolute. But that means all value here is positive. So this is equals to, substitute the value. This is 10.06 newtons divided by 17.75 newtons, absolute value. Okay, now, so cancel out this one. Newton divide Newton, cancel out the units here. And this becomes, based on my computation, the equation becomes tangent theta. We're going to transfer this one, this tangent function here to that. So this becomes inverse tangent times 10.06 over 17.75. Let's try to recheck first. R sub y is this one. The value is here. It's correct. R sub x is adjacent. So this one, the value is okay. So correct. And perform the mathematics of this one using your calculator. The answer is, try to verify my answer because I just used a mobile phone calculator. So my answer based on my computation here using my mobile phone calculator, the angle is equals to 29.54 degrees. So this will be my angle. Now to express our final answer is, I will write this here. Final answer is resultant vector is equals to 20.4 newtons. Angle is 29, or we will copy that one, 29.54 degrees. The direction is this one. R sub x is going to west, and this is or we can rewrite this one as like this, south of this is north, this is north of west, or I can also rewrite as 20.4 newtons west, 29.54 degrees north. So either of these two solution or answer here is correct. So you can express your answer like this, or you can express your answer like this one. So this way, this is now the final answer. Meaning, the answer for this problem, the resultant vector of these three vectors is 20.4 newtons, and the direction is west, 29.54 degrees north. So that would complete our solution in this problem. I will just send you the picture of this one, the JPEG copy of this one in our group chat, so that you can easily copy our solution here. So that would be all. If you have some clarifications regarding the process, I am always happy to hear from you in our group chat, and I will try to answer your queries. That would be all. Thank you so much for listening and spending your time for this topic. This will be the end of our module number 2 for this week number 2. Thank you so much, class, and see you in the next video. God bless you all and keep safe.